This is a lesson video for 7-3 Day 1. There'll be plenty of place in this video where you need to pause it, complete something, and then come back. For your own understanding, it's critical that you do that. So as we worked through different methods for integrating functions, integrating curves that they gave us, we used known antiderivatives at first. Eventually we used area models and other things like that. And then we came to realizing that certain integrands would have had chain rule applying, and therefore we used U substitution in order to undo a chain rule and figure out what the function had been before its derivative was taken, or the equation. So pause the video and do these two with known antiderivatives on the first one, substitution on the second one, and come back when you've got them. Pause now. If you're back, you're checking that with known antiderivatives, you could get to the equation that's shown here as far as coming up with what the function had been. And then from substitution, we had basically the derivative, and we had to come up with what the function or the family of functions had been that had come from. And again, pause the video here if you need to go back and rework something. What we end up getting to, however, is some integrands, like the one that's showing, that we don't have a method for. If we tried this by known antiderivatives, we don't know any equation that x cosine x is the derivative of. Also, by substitution, no matter what we choose in here, we aren't able to actually take all of the parts and use them, and therefore we need additional methods. So we will definitely come back to this one after we talk about that additional method. So a method that's not included in AB, but we do afterwards because it's often included in Calc 1, is called integration by parts. And it comes from undoing what product rule produced as a derivative. So it's not a replacement method, it's really an extra tool for ones that we don't already have a method for. So we know, because we can remember all our rules about taking derivatives, you can see here that I've got product rule, the derivative of that product, and we know how to do that. The first function times derivative of the second, and then added with the second function times derivative of the first. We need a way, however, to think about undoing this. So here's what we know, is that if uv prime, meaning its derivative, is what's shown, then we should be able to get back to the function, the two functions, u times v, if we were to, and I know this all pops up at once, but go through it slowly with me and we'll highlight as we talk through. If you were to go through, it should be then the integral of all of that should get us back to the two equations that it had come from. The problem is a lot of the equations don't look like that at first. So as a way of working around this, there is a method by which we can do that. And this is going to go through that process. Saying, okay, if that's what I would really want, and this is kind of the proof of where this formula comes from, then I would split this into two integrals, as shown here. And then I do a little notation replacement. V prime can get replaced with dv dx, meaning v's derivative with respect to x. And u prime can get replaced with the other notation for it, which lets us cancel out some dx's. We end up with this weird integral that ends up being the integral of the function u of x times dv plus the integral of v of x times du. Moving this around, we come up with a formula or a recipe, and again, pause the video here, for how we will be able to take an integrand, and if we can split it up into a function and then the derivative of another function, if we can split the integrand up somehow into these two pieces, then here's the recipe or the formula for getting its antiderivative. So pause the video here and make sure you kind of have this in pieces so you can see where this comes from. So I put the equation in the top corner. In other words, how we're going to work with undoing a product in order to come back up with where it came from, what its antiderivative is. We will definitely work in the next few days on how to pick these pieces, but for the moment, you've got some steps sitting here, and it says we need to pick which part of what we have here in the integrand are we going to consider our function, and which part are we going to make into the dv part. So in other words, we need to creatively split this up. So as we do this, like I said, in the beginning, we're going to make suggestions. So we're going to suggest that the part we consider u be the x, and the part that we consider the dv be the rest of it at this moment. Cosine of x dx. In other words, we are going to be splitting what that integrand has into something we can take the derivative of and something we can integrate. So as we go from u, we're going to take the derivative of u so that we get a du. And du it'll be done with respect to x's, and therefore its derivative would be 1, so that we know our du is dx. On this dv, we're going to integrate both sides so that we can come up with what v had been. In this case, the integral of cosine is sine. Notice we're not putting plus a constant in here at the moment. So in that first step, we picked our u and we picked our our dv. In other words, split up that integrand so that we can come up with an expression for du, and we came up with an expression for v. Again, pausing the video where you need to catch up with this idea or to slow it down. Then we're ready to put it into this format that said if you were able to split your integral up into those two things, then here's the recipe for its antiderivative, for its integral. So as we do that and we put it into the formula, I am now saying that the integral I wanted in the first place, which is how they gave it to us, x cosine x, and I'm missing a dx in there, so please forgive. Put that in there, is, and here it goes into the set formula. And then evaluating that integral and adding the constant. Again, pause the video here. Catch up with this slowly. Add in the dx's so that your math notation is better than mine. Now, to make sure that this is really the antiderivative, we're going to check it with derivatives. So if this is truly x sine of x plus cosine of x plus a constant is truly that function or function family, I should be able to take the derivative and check that it gets back to x cosine of x. So work through that and see that it does. Then when you're ready, go on to the next example. So we have one more to try this out on, and tonight's assignment is going to be a very brief, making sure you can just split the integrand into two parts, and then we'll keep working on more of those things as we go. The idea here is we need to split up that ln of x dx. We need to split it into something we can take the derivative of and something we can integrate. The dx will always go with the part we're trying to integrate. So if I were picking my u and I were picking my dv, dx for sure has to be part of the dv because I can integrate if I have those differentials in there. I'm going to make my u ln of x. So I need to split up all of the notation in there in order to be able to use this by parts method. And once I do that, then I'm going to calculate u's derivative with respect to x and dv's integral with respect to x. Once I have those, the formula basically says that the integral that I'm interested in is, and I'm going to kind of show this in a method, these two multiplied together, minus, and then again, look for the formula up in the corner here, the integral of these two. So as I go to put this into the formula, oops, darker green. Okay, as I go to put these into the formula, that integral of ln of x dx that I was interested in the first place, it's going to be that x ln of x minus the integral of x times 1 over x dx. Once all the parts are in, then I can start to clean that up, evaluate, and add my constant. So that should get me to my expression. And again, algebraically cleaning that up. Pause the video each couple moments so that you can catch up. Then I need to check that with derivatives. Essentially, I want to take the derivative of that family of curves and make sure that it gets me back to natural log. So as I go to do that, and I take the derivative of that expression, we need a little product rule on the x ln x. But when we do, and you can clean it up, you see that we get back all the way to the equation ln of x. So what's coming? More ideas on how to break up that integrand into this idea of that function we call u and the part we're calling dv. Your assignment on the worksheet that's day 1 is to do all of the ones for part A and part B in the directions, and the directions are about halfway down the page. And then I added a part C for ones that have an asterisk. Please make sure that you do that.